Hey fifth graders, today is the last day we're going to be spending on this topic in this last video that I'm going to be creating for coordinate planes and understanding how problems are represented in coordinate planes. And we're going to be practicing three of the big categories and different subtopics that we learned about in previous videos. Okay, so with that we're going to just be plotting different ordered pairs. Okay, and understanding the distances between those ordered pairs is the second big topic. And then the last one we're going to talk about and learn about and practice is how coordinate planes shows the relationship between two quantities. Okay, so we're going to start out with number one on page 675. So I'm going to write that over here, page 675. And today we're going to end. We are going to end on page 677, okay? And these are all in your packets, okay? So make sure that if I move on to a new problem, make sure you follow along and move to a new page in your packet, okay? All right, so here we go. First one's a really long one, but if you take it step by step, it's a little bit simpler than you think, okay? So it says, plot the points 4, 4, 8, 4, 3, 1, 7, 1 in the coordinate plane. Use the points to draw two parallel horizontal segments. Label the endpoints of one segment AB. Label the other endpoints of the other segment CD. What is the distance between points A and B? What is the distance between points C and D? Okay? So here, it's like a 6-step problem. But the way to simplify this problem is I'm going to break it up and do one step at a time. Okay? So I'm going to do the first one, and I'm going to plot these 4 points that it tells me. So the first one is 4, 4. And I know when I go to plot points, I know that the x-coordinate comes first in an ordered pair. So I always plot my x-axis first. So the first one is 4, 4. So I go over 4 on the x and up 4 on the y. There we go, I plot it there. Okay, 8, 4. So I go 8 over on the x, up 4 on the y. And I plot my point. Good. Then I have 3, 1. So over 3 on the x, up 1 in the y, and then I go over 7 and up 1 on the y. So over 7 and up 1 on the y. Very good. I plotted my 4 points. First step done. Then it says use the points to draw two parallel horizontal line segments. So what that means is we have two big vocabulary terms from last week's topic. Okay? Parallel lines mean they're opposite of each other, and they are parallel to each other, meaning they are straight across one another. Those would be two parallel lines. Okay? So, what I notice here is that two of my points on different axes have the same number. So what that means is, on the y-axis, I have 2 points at 4, and on the other y-axis, I have 2 points at 1. So, to connect those, I would draw a horizontal line. Horizontal meaning side to side. Okay? So, horizontal line connecting the first 2 dots, horizontal line connecting the second 2 points. Creating 2 horizontal and parallel lines. There we go, step 2. All done. Then it says, label the endpoints of one segment AB. Okay, I'm going to lay it. So remember, a line segment is a connecting of 2 points. So I can't label this one A and this one down here B. Those are 2 different line segments. I have to connect and label the same line segment. So I would go with my top one. A and B are connected. There's one line segment. Alright, step 3 done. Then it says label the endpoints of the other segment CD. Now I have one other line segment. And I would label it C and D. Step 4, done. Step 5 says, what is the distance between point A and point B? Now remember, I treat axes as number lines. So each tick mark I pass is 1 unit. So if I look at A, I would notice that I have 1, 2, 3, and 4. 4 units for line segment AB. Done with that one. And my last step, it says, what is the distance between C and D? Once again, I would treat these coordinate planes as number lines, and I would say it is 1, 2, 3, and 4. Both of them 4 units long. And that is that. 6-step problem, finished, okay? Don't get discouraged from these problems. Take it step by step. All right, next. And you guys are going to be turning your page to page 676, okay, 676, because we're working on number 2, okay? And it's going to revisit a topic that we have done all year, okay, with different topics. It says, what is the area of rectangle EFGH shown in the coordinate plane? Now, why do they call it EFGH? Why do they call this rectangle EFGH? Well, they call it that because all of the different coordinates represent a labeled letter. And so if all of those labeled letters are connected, that's what we call that shape. Okay? All right, so key term in this problem is, what is the area? Area. Okay, you guys know how to find area, and I still have it written in the corner of my whiteboard. It's been there all year, guys. But just as a reminder, area is found by multiplying length times width. Yes, and that should be light bulbs going off here, okay? So, in this problem, we don't have to find perimeter. Perimeter is different. Perimeter is just the length of the outside edges. Area is finding everything in here, the space in the two-dimensional figure, okay? So we only have to find a length, we only have to find a width. Okay, remember length goes side to side, so let's start with finding length from F to G. It is 1, 2, and 3 units. 3 units for my length. Okay, so if my top length should be the same as my bottom. Now let's find our width. Alright? Remember, we treat these just like number lines like the previous problem. Okay, so I have 1, 2, 3, 4. My width is 4 units. Now, I go back to my equation. Area is length times width. So, my length, I said, was 3 units, times my width, which is 4 units. And I know my math facts, 3 times 4 is, you got it, 12 square units. Square units, right? Two-dimensional figure, we use square units. And there you have it, guys. The area of rectangle EFGH is 12 square units. Nice work. All right, guys, we're going to stick to page 676 in your packet for number 3. Okay, number 3. In this one, we're going to be working and practicing the subtopic that we learned a few days ago about traveling on a coordinate plane. Okay? All right, so here we go. It says, Mr. Palmer uses the coordinate plane to design his bulletin board. Excellent. Thank you for the story, but unneeded information. Says he moves rules, okay, and I see rules right here. I'm going to point that one out. He's moving rules, bulletin board, right there. Okay, he's moving rules right 2 units and 3 units down. What ordered pair represents the new location of rules? So, 2 units to the right, 3 units down. Okay, well, I have rules right here. Now remember, I treat it just like number lines, so I need to move 2 units right and 3 units down. And I can only move along lines on the coordinate plane. So, I have rules here. I move over to the right 2, and then I move down 1, 2, and 3. And my new coordinate plane is right there. And it says, what's the new location? Well, I plotted the new location for rules, and now I need to find its ordered pair. Okay, so in my ordered pair, we already know, just a quick reminder, x coordinate comes first, y coordinate second. So, my x-coordinate lines up with 5 along the x-axis, so I have 5. And it lines up with 3 along the y-axis. So my new location should be 5, 3, which is letter A. Okay, but there's 2 parts to this problem. Alright? It says down here, Maya chose C as the correct answer. How did she get that? Okay, I'm going to leave the lights off and finish this problem up real quick. Well, if Maya got C here, it's 1, 3. So we have the same y coordinate. So you know what I bet you she did? I'm going to do exactly what I think Maya did. I think instead of going right 2, like the directions told us to, she went over to the left 2 and then down 3. She would get 1, 3 if she would have done that. So extremely, when we're traveling on the coordinate plane, extremely important to understand that we have to pay attention to the directions. Okay? Alright guys, we're moving over one more page. We're going to practice 2 more, and my favorite topic in this entire video is going to be showing the relationships between 2 quantities. Let me get the lights. Okay, so last video we practiced and learned about how to show relationships of quantities, and that's what we're going to do here too. Okay? Alright, I'm going to use green for this one. It says, the coordinate plane shows the relationship between the amount of water in a bathtub and the amount of time the faucet has been turned on. Okay? So if I actually look at the coordinate plane, my x-axis says time the faucet's been on, and my y-axis shows how many gallons of water would be in the bathtub. So, each one of these points shows the relationship between how many minutes the faucet's been turned on and how much water is in the bathtub. So pretty simple, right? So I have one question to answer here. It says, what do the coordinates of the point 3, 6 represent in this situation? So I'm going to develop a pretty, like 15, 20 word sentence to represent what that one point on that coordinate plane shows. So it says 3, 6, so I see x3, y6, and that, what does that point right there mean? What does that little dot on that coordinate plane mean? Well, it means that if the faucet has been on for, remember, x-axis is minutes on, for 3 minutes, the bathtub will have how many gallons? Well, follow your coordinate plane and its labels. I already identified that it's been on for 3 minutes, meaning the bathtub will have 6 gallons of water. So the bathtub will have 6 gallons in it. Pretty long sentence for representing just one teensy little dot on a coordinate plane. But that's what these relationships mean, okay? Instead of writing these big long sentences, I can just show those relationships in a coordinate plane, because I know you all love writing. Alright, so I'm not going to move on to the next slide, but we're going to learn and do 5 and practice 5, because I'm going to need that coordinate plane to do so. So go ahead and just look at 5 and read along with me. It says, use the coordinate plane from the problem 4. How many minutes must the faucet be turned on for there to be 8 gallons of water in the bathtub? So remember, our coordinate plane is showing the relationship of how long the faucet's been on to how many gallons that would fill the bathtub. So really the relationship between time and gallons is for every minute, 2 gallons of water is filled in the bathtub. See? 1 minute, 2 gallons. 2 minutes, 4 gallons. 3 minutes, 6 gallons. So, every minute the faucet is on, 2 gallons of water fills up, right? So, if 2 more gallons, because it already tells us that there's 8 gallons of water in the bathtub, and we have to determine how much time that bathtub, or that faucet was on. So, if I notice, my last plotted point is 6 gallons. So my next one would be 2 gallons up from 6, which meaning it's 8 gallons. So what would I have to do? I know that if it filled up, the tub filled up 2 more gallons, the faucet must have been on 1 more minute. So if 6 gallons is filled up with 3 minutes, that means 8 gallons is filled up, and the faucet must have been on for 1 additional minute, meaning it was on for 4 minutes to get 8 gallons. Okay, so you should have letter B circled. Alright guys, you got 3 more problems on page 677 and page 678. Follow along with your teacher's manual, practice the problems, and you should be ready for the quiz. Alright guys, good luck and see you soon.